So, it is July 17th, 2026. And today we're getting into something that, honestly, it kind of changes how you look at flying.
Yeah, it really does.
Because I want you to imagine, boarding a flight. You settle into your window seat, you buckle up, and, well, up at the front of the plane, there's a pilot,
Right.
and you implicitly trust that pilot. I mean, you kind of have to.
You don't really have a choice once the doors close.
Exactly. But the reality of modern aviation is that your life is actually equally in the hands of someone you will never, ever meet.
Yeah, someone entirely invisible to you.
Right. Someone who might have turned a wrench or applied a sealant or tightened a bolt on that exact aircraft, but they did it hours or days or maybe even years ago.
It is this totally invisible line of trust. We obsess over the person flying the machine today, right?
Mm-hmm.
But the integrity of the aircraft actually relies on the person who maintained it last month.
Or last year.
Or last year, yeah. And right now, the system that trains those people, the mechanics, it's facing this massive, just structural crisis.
Which is exactly what we are unpacking today. We are doing a deep dive into a really fascinating new initiative from EON AI Ventures.
Oh, yeah, the Aerospace MRO Situation Room.
That's the one. And just to, clear the runway on the jargon really quick, MRO stands for maintenance, repair, and overhaul.
It's the invisible backbone of the entire airline industry.
Truly, if the MRO ecosystem breaks down, nothing flies. But right now, they are trying to solve what looks like, honestly, an impossible math problem with their workforce.
It really is an impossible math problem if you look at their current trajectory. I mean, over the next 20 years, Airbus and Boeing are forecasting that the industry needs to hire and train over 600,000 new aircraft maintenance technicians.
Wait, 600,000?
600,000 new mechanics, yes.
That is a staggering number of people to try and filter into a high-stakes environment.
It is. And it's not just about, expanding the workforce because there are more airplanes flying.
Right.
The really terrifying part is that the vast majority of those new hires, they're replacing a retiring generation.
Yeah. Ah, okay. The baby boomer is aging out.
Exactly. You have this massive wave of highly experienced technicians, these veterans who have literally seen it all, and they are leaving the hangar for good.
So all that knowledge just walks out the door.
It walks right out the door. And the critical loss isn't just, a shortage of warm bodies turning wrenches. It's the loss of what the industry calls tacit judgment.
Okay, tacit judgment. I actually want to spend a second on this because it's a phrase that gets thrown around in corporate literature all the time. But on a hangar floor, what does tacit judgment actually look like?
Yeah, it's a great question. So tacit judgment is the knowledge that isn't written down in the official maintenance manual.
Oh, like the unwritten rules?
Right, but it's very sensory. It is a veteran mechanic just knowing the specific high-pitched metallic ping that a properly torqued bolt makes.
Wow, okay.
It's feeling the exact right tension on a flight control cable and feeling it through a thick pair of work gloves.
Yeah.
Or, it's the ability to smell a specific hydraulic fluid leak before you even see a drop of it on the floor.
You definitely cannot teach that on a whiteboard.
No, you absolutely cannot.
It's almost like a world-class restaurant losing all of its master chefs on the exact same day.
That's a really good way to look at it.
And so you're left with a kitchen full of brand new, totally green cooks who have never actually survived a chaotic Friday night dinner service.
Yes. But obviously the stakes in aviation are a little higher than a ruined souffle.
Considerably higher, yeah.
Because maintenance error is actually a contributing factor in roughly 1 in 8 major aviation accidents.
1 in 8? Wow.
Yeah. And it is also the primary cause of a huge share of in-flight engine shutdowns.
So obviously, regulators know this is a problem, right? Like the FAA here, or EASE in Europe.
Oh, they definitely know. They mandate recurrent human factors training to try and prevent these exact errors.
Right. But looking at the press release and the data EON is using to build their new platform, the current state of that training seems aggressively inadequate. I mean, they literally call it a forgettable slide deck.
Which is an incredibly dangerous way to train someone for a highly physical, high-stakes job.
Yeah, clicking through PowerPoint slides doesn't really scream life or death.
Exactly, because knowledge in aviation maintenance isn't just about rote memorization.
Right.
It's not, a multiple choice query where you just match a regulation number to a definition. It's about recognizing context.
The context that a slide deck can't provide.
Right. The current slide deck approach completely fails to replicate the environmental pressure. It doesn't simulate the fatigue or the poor lighting or, the spatial confusion of working upside down inside the cramped belly of an aircraft at 2 in the morning.
Man, that sounds miserable. And it completely misses the psychological nature of making an error in that specific environment.
Yes, the psychology is the biggest part.
Which brings us to this term EON uses for this specific psychological blind spot. And I'll be honest, reading this part gave me chills. They call it the two-date signature.
The two-date signature. It is basically the anatomy of a quiet disaster.
Yeah, this is where the core problem really crystallizes for me. Because the defining characteristic of a maintenance error, the signature of it, is that the error is committed quietly.
Very quietly.
Right. There is no spark, there's no loud bang, no alarm bell goes off in the hangar to tell you that you messed up.
The accident always arrives later.
Exactly. The first date is the mistake, but the second date is the consequence. And sometimes that gap is hours, sometimes it's days, and sometimes it is literally decades.
And that accident eventually happens to a flight crew and a cabin full of passengers who, like we said earlier, never met the technician who made the mistake.
Right.
EON explicitly builds their entire Situation Room curriculum around this exact terrifying gap in time.
The historical examples they use in the source material to illustrate this are just mind-blowing. Like, they mention the British Airways Flight 5390 incident.
Oh, the windscreen blowout.
Yeah, the famous one where the wrong bolts were used on a cockpit windscreen and it blew out mid-flight. It literally nearly pulled the captain out of the plane.
Terrifying incident.
But the gap there was the 27-hour gap between the mechanic putting in those wrong bolts and the window actually blowing out.
Right.
But then they cite the Japan Airlines Flight 123 tragedy. That was a flawed repair on a rear pressure bulkhead. And the gap there, it was 7 years.
7 years.
A staggering 7-year gap. I mean, it is like accidentally setting a ticking time bomb, but you have absolutely no idea. You even touched the timer.
Yes.
And then you hand the box off and it just gets passed around for 7 years until some complete stranger is holding it when it finally goes off.
It is a totally haunting reality. But I want to look at this from the perspective of the new green technician who's actually trying to learn the job.
Okay, sure.
Because human beings generally learn through immediate feedback loops.
Right. Like cause and effect.
Exactly. You touch a hot stove, it burns your hand, and you learn in a fraction of a second not to touch it again.
But wait, let me play devil's advocate here for a second. Aviation is literally the most heavily scrutinized, double-checked, audited industry on the planet. So you're telling me a mechanic doesn't get told immediately if they mess up a repair? Someone doesn't catch it?
In many cases, no, they don't, because a latent failure is invisible.
Okay, explain that.
Sure. So a technician might perform a safety-critical task incorrectly. Let's say they skip a lubrication step on a jack screw, or maybe they use a bolt that is literally 1 millimeter too short.
Something tiny.
Right. So they sign off on the paperwork.
Mm.
But the inspector might only be able to see that the access panel is closed and the paperwork is signed. They can't see the missing grease inside the mechanism.
Oh, wow.
So the technician goes home and the plane flies perfectly fine the next day and the next week and the next month.
So they don't get burned by the hot stove.
Exactly the opposite.
Duh.
Psychologically, their brain tells them, hey, I did that task correctly because the plane is flying safely.
Oh, that is so dangerous.
It is. Their bad habit solidifies. They have absolutely no idea. They just initiated a two-date signature. And by the time the consequence actually arrives years later, that technician might be working at a totally different airline, or they might have been promoted to management. The feedback loop is completely broken.
Which forces this massive question. I mean, if a mechanic cannot learn from their own mistakes because the feedback loop just doesn't exist, how do you teach them to survive?
And EON's answer is pretty radical, they say. You have to make them experience someone else's mistake.
Right. You have to close that gap.
Exactly. Which brings us to the actual MRO Situation Room itself. They are essentially saying that reality is the ultimate curriculum.
Right. They describe this whole thing as a cinematic Netflix-style catalog of real historical maintenance accidents.
Yeah, that's the interface.
And the pilot library they are launching currently contains 31 specific cases. But the scope of this is massive. I mean, they aren't just looking at engines.
No, it's comprehensive.
They are covering power plants, landing gear, hydraulics, flight controls, fuel systems, avionics, cabin pressurization, structural repairs. They even built a satellite assembly integration and test extension.
Right, so it covers virtually every critical system where human hands physically interact with aerospace engineering.
But the crucial principle here, the thing that separates this from just another boring corporate training video, is the sourcing.
The sourcing is everything.
Right, because everything in this catalog is strictly grounded in official government investigative reports. We are talking about the NTSB in the US, the AAIB in the UK, the JTSB in Japan, the BEA in France.
The heavy hitters.
Exactly. Every single statistic is cited. Nothing is invented for dramatic effect. And they make a massive point of noting that carriers are named exactly as they appear in the offending reports.
Which, when you think about it, is a profound structural decision for a corporate training platform.
Yeah, I really want to push back on this, actually, because from a business standpoint, it feels like a massive risk.
How so?
They're using the exact real names of the airlines involved in these tragedies. And airlines are incredibly protective of their public relations, right?
Oh, fiercely protective.
They spend billions crafting a safe, reliable brand image. So won't an airline absolutely reject a training tool that forces their mechanics to sit there and stare at their own logo attached to the darkest day in their company's history?
It does seem completely counterintuitive to how corporate training usually works, because normally everything is heavily sanitized.
Right, Airline X.
Exactly. But by pulling strictly from public official investigative reports, EON is doing something very, very strategic. They're completely neutralizing liability and internal office politics.
Wait, how does using a real name neutralize the politics?
Because the NTSB or the AAIB reports, they are public legal records.
Okay.
The investigations have already concluded, right? Sometimes decades ago. The fault has been legally, scientifically, and technically established by a sovereign government.
I see.
So by restricting themselves exclusively to these specific documents, EON N turns what are normally highly emotional corporate tragedies into objective, indisputable data.
You can't argue with the NTSB.
Exactly. In a safety-critical field, truth has to trump public relations. If you try to sanitize the event, if you say, let's look at an incident at Airline X instead of saying Alaska Airlines or Japan Airlines, you remove the visceral reality.
You make it a hypothetical.
Right. You dilute the lesson. The green mechanic needs to know this isn't a fable. It is a historical fact that happened to real people.
Okay, yeah, that makes total sense. By leaning into the unvarnished truth, they make the stakes very real for that 20-year-old technician.
Exactly.
But translating a 30-year-old paper NTSB report into a lesson that actually builds real wrench-turning skills on a hangar floor, that requires a massive technical leap. I mean, just watching a documentary doesn't give you tacit judgment.
No, it doesn't.
So how are they actually doing that?
This is where we shift from the narrative approach to the underlying technology. EON N refers to this whole system as their technological flywheel.
The technical architecture here is really fascinating. They talk about having a library spine.
Right.
So these 31 accident cases aren't just standalone videos. They link directly into what EON calls their Aviation Living Library, which contains 50 equipment classes based on the ATA ISPEC 2200 standard.
Let's actually translate that standard really briefly.
Yeah, please do.
So the ATA ISPEC 2200 is essentially the universal Dewey Decimal System for global aviation.
Oh, okay.
It's a standardized numbering system for aircraft systems. So it means that an aircraft mechanic in Tokyo and an aircraft mechanic in Chicago both know that Chapter 32 in any manual is always landing gear.
Regardless of what plane it is.
Right. And Chapter 29 is always hydraulic power, regardless of who built the airplane.
So they map the tragedy directly to this global maintenance language.
It's
And they give a really specific example of how this spine functions in the source material. So if a technician opens the Alaska Airlines Flight 261 case in the Situation Room, it doesn't just, tell the story of the crash.
right. It goes deeper.
The narrative actually acts as a doorway. It takes the user directly to a highly detailed 3D digital model of the exact jack screw actuator, specifically the ball screw and the no back brake, that failed in real life.
Because the Situation Room is really merely the front door, it actually sits inside a much larger, complex tech stack that EON calls their work intelligence flywheel.
Right, and instead of just listing off the software names, let's kind of explain how they actually interact, because it's like they are building a digital universe from scratch here.
It really is.
So first, they have a layer called Genesis, which is essentially writes the laws of physics and the procedural steps for this digital universe.
Yep.
Then a layer called EON Universal acts as the spatial blueprint. It basically understands where all the components are and how they fit together in 3D space.
Right.
Next is EON Live, which is the actual real-time physics engine driving everything. Then the Situation Room layers the historical tragedy on top of that physics engine.
It's building layer by layer.
Exactly. And finally, a tool called Field IQ pushes all of this combined knowledge directly onto a tablet or a headset right on the hangar floor.
So just think about the pedagogical shift here for a second. You start with a story of a failure.
Right.
That story opens up into a 3D digital twin of the component.
Okay.
And then that digital twin opens up into a playable, interactive mission. The technician can literally step into the shoes of the mechanic from 1990.
Wow.
They can run the exact maintenance procedure that the real crew skipped or botched or completely misunderstood. And because of that EON Live physics engine, they experience it with real-world physics.
Wait, so if I'm the green mechanic in this simulation and I decide to apply the wrong torque to a virtual bolt, or, I skip applying grease to a specific fitting, what actually happens?
The simulation reacts exactly as the real world would, but instantly.
Really?
Yes. So if you over-torque the bolt, the simulation calculates the physical stress, and the virtual threads literally strip in your hands.
Oh, that is crazy.
If you skip the lubrication step, the simulation models the friction, it models the heat buildup, and eventually the mechanical binding of the metal. You get the immediate visceral feedback that the real world normally denies you.
You touch the hot stove and it burns you right then and there.
Right then and there.
It closes the to-date signature. You see the consequence on the exact same day you make the error.
Precisely. It builds that tacit judgment, but it builds it virtually.
But there is a very specific technical choice EON N makes here that I want to drill into because it confused me at first.
Okay.
The architecture dictates that EON N models components, not whole aircraft types.
Yes, that's a key distinction.
They explicitly note that a single engine model in their system spans a small piston aircraft, a massive wide-body jet, and even a satellite. Why does it matter that they model a component instead of just, building a highly detailed digital twin of a Boeing 737 or an Airbus A350? What is the strategic advantage for the mechanic learning this stuff?
It is a massive paradigm shift in scalability.
How so?
Think about the fundamental laws of the universe. Physics is physics, right? A hydraulic valve failing under high pressure operates under the exact same physical laws, whether it is installed in a tiny Cessna training plane or a multi-million-dollar space satellite.
Okay, I see where you're going.
By modeling the components and the physics behind them, basically the DNA of the machinery, rather than building a bespoke, highly customized digital twin of every single airplane ever manufactured, EON is building a universal language of mechanical failure.
So they aren't teaching a mechanic how to fix a 737 specifically.
No.
They're teaching them the DNA of how a hydraulic actuator fails across the entire universe of machinery.
Yes, because if you understand the DNA of a hydraulic failure, you could apply that tacit judgment to literally any aircraft that rolls into your hangar.
Which makes them valuable anywhere.
Exactly. It accelerates the learning process exponentially,
Yeah.
making that green workforce competent so much faster.
All right, so this tech stack sounds amazing. It sounds like science fiction, honestly. But let's ground this conversation back in the present day. It is July 2026. Where is this actually being deployed in the real world right now? And, what are the hurdles?
Well, the deployment strategy is highly targeted right out of the gate.
Okay.
The product is designed to be generic, global, and English first, though they do note it is built to be localization ready for other languages down the line.
And they are targeting a very wide audience with this. They want this in airlines, internal engineering, and MRO organizations.
Yep.
They are aiming it at independent repair shops, what the industry calls Part 145s, and national aerospace centers. They also want it in the mechanic training schools, the Part 147s.
Basically anywhere mechanics learn or work.
Right. And they actually announced their first major showcase deployment alongside this press release. It's located at the El Dorado Aerospace Intelligence Center in Bogota, Colombia.
Which perfectly highlights just how truly global the aviation maintenance network is.
Yeah, totally.
I mean, your plane might be flying domestic routes in Europe or the United States, but it could easily be sent down to South America for heavy maintenance.
And EON actually has the weight to push this globally, right? They aren't just some startup that appeared out of a garage yesterday.
Oh no, they have 25 years of experience in immersive learning. They currently support over 4,400 institutional customers across more than 80 countries.
It's a massive footprint. But Looking closely at the release and how this is being rolled out, there is a major caveat here, a really big regulatory asterisk.
Ah, yes. The certification reality check.
Right. The documentation states that the MRO Situation Room pilot is complete. It's currently in review. But it is explicitly positioned as a rigorous human factors resource, not a certified training device.
That is a very important distinction.
EON states clearly that they make no regulatory training credit claims pending a certification partnership. So wait, let me get this straight. After building this massive, physics-based, historically accurate, incredible tech stack, an airline can't even use this to check off their mandatory regulatory training box for the FAA.
That's correct. An airline cannot use this to legally replace their mandatory regulatory slide deck today.
That is wild to me.
But this points to a much broader strategic pattern that we see constantly in heavily regulated safety-critical industries.
Which is what?
Innovation almost always outpaces regulation.
Just because the bureaucracy is too slow?
The bureaucratic machinery moves incredibly slowly by design.
Mm.
I mean, when you are regulating aviation safety, you do not move fast and break things.
Right, because lives are literally at stake.
Exactly. So the regulators are inherently and rightly conservative about adopting brand new training methodologies.
So EON is essentially building a massive tool for a regulatory framework that just doesn't even exist yet. Isn't that incredibly risky for them as a business?
Well, it's the classic build a better mousetrap strategy, but applied to complex aerospace engineering. They are actually playing it very smartly. They know the bureaucracy won't certify a theoretical concept. So they are building the definitive, undeniable tool first.
Build it and they will come.
Right. They are deploying it in active environments like Bogota to prove objectively that it works on the actual hangar floor.
You want the data.
Yes. They're gathering the data to show that it genuinely reduces maintenance errors and successfully builds that tacit judgment in young mechanics.
So they are establishing the undeniable value of the platform out in the wild.
Exactly. Seeking the bureaucratic certification partnership is step 2.
Ah, I see.
Once the airlines and the MROs realize they simply cannot operate as safely without this technology, the industry itself will pressure the regulators to figure out how to certify it.
Mm.
They're basically forcing the regulatory framework to catch up to the technological reality.
Which is an incredible place to find ourselves in, really watching an industry try to literally drag its own safety standards into the future.
It's fascinating to watch.
Let's briefly recap the journey of this depth dive because we've covered a lot of ground today.
We definitely have.
We started by looking at a terrifying demographic reality, this looming shortage of 600,000 aviation technicians and the mass exodus of an entire generation's worth of unwritten tacit knowledge.
And we examined the insidious nature of the two-date signature, that chilling psychological gap between when a quiet mechanical error is made and when the catastrophic consequence finally arrives years later.
Right. And we saw how EON AI Ventures is attempting to solve this impossible math problem. They are basically taking those forgettable, check-the-box regulatory slide decks and replacing them with a cinematic, deeply researched situation room.
A huge upgrade.
Taking official, objective accident reports from the NTSB, turning them into 3D digital twins, and creating playable live physics missions.
It's brilliant. It allows a 20-year-old technician to experience the deadly consequences of a mistake immediately.
Which builds tacit judgment without ever putting a real passenger in danger. It is a fundamental paradigm shift in how we transfer critical, life-saving knowledge from an older generation to a younger one.
It really is a massive leap forward for aviation. But, it leaves us with something very important to consider outside the hangar, too.
Oh, what's that?
Well, the aerospace industry is mapping out these deadly two-date signatures using advanced AI and physics engines because human lives are explicitly on the line.
Right.
But I'd ask you to think about your own industry, your own daily work, or even your own personal life.
Okay.
What quiet errors are you or your team making today that won't actually show their true consequences for months or even years?
Oh, wow.
And if you don't have a virtual situation room to show you the future, how will you catch those mistakes before the clock finally runs out?
That is a heavy, essential question to leave you with. You might not be torquing a bolt on a 777 today, but we all have our own invisible lines of trust and our own delayed consequences. Thank you so much for joining us on this deep dive into the MRO Situation Room. We'll catch you next time.